Hey everyone, Linus here. Welcome back to another deep dive into the tech world. Today, we're diving into the fascinating world of Android traffic analysis, a topic that's both intriguing and essential for anyone who wants to understand their device better. You know, that thing your phone does 24/7, sending and receiving data. It's like a constant conversation happening in the background. Ever wondered what it's actually up to? What kind of data is being sent and received, and why? Well, with traffic analysis, we can peek behind the curtain and see the magic happen. It's like having a backstage pass to your phone's inner workings. Think of your Android device as a bustling city full of activity and constant movement, and the data it transmits as cars traveling on a network of roads. Each piece of data is like a vehicle with a specific destination. Traffic analysis is like setting up cameras and checkpoints throughout this city, monitoring the flow and ensuring everything runs smoothly, allowing us to observe the flow of vehicles. We can track their routes, understand traffic patterns, and even predict potential issues. We can see where they're coming from, where they're going, and what they might be carrying. It's a comprehensive view of your device's data traffic. This might sound a bit creepy, like someone is watching your every move, but it's actually incredibly useful for a variety of reasons, from troubleshooting network issues to identifying security vulnerabilities. It helps keep your device secure and efficient. Whether you're a developer, a security researcher, or just a curious tech enthusiast, traffic analysis offers invaluable insights. Understanding traffic analysis can give you a powerful set of tools to understand and optimize your Android experience. So, let's get started and explore this fascinating aspect of technology together. So, why is Android traffic analysis so important? Well, for starters, it helps us understand how apps on our devices communicate with the outside world. This communication is the backbone of how apps function, sending and receiving data to provide services, updates, and more. By analyzing the data they send and receive, we can gain insights into their functionality, performance, and even their security posture. This means we can see if an app is working efficiently or if it's sending unnecessary data that could slow down your device. For developers, this is invaluable information. It allows them to refine their apps, ensuring they run smoothly and securely. Imagine being able to pinpoint the source of a network bottleneck in your app or identify potential security loopholes before they become major issues. This proactive approach can save time and resources in the long run. Traffic analysis provides the means to do just that. It offers a detailed view of how data moves through the network, highlighting areas that need attention. On the security front, traffic analysis is crucial for detecting and preventing malicious activity. It acts as an early warning system, alerting us to potential threats before they can cause harm. By monitoring network traffic, security researchers can identify suspicious patterns, track malware infections, and even uncover hidden communication channels used by attackers. This level of insight is essential for maintaining the integrity of our digital environments, but it's not just about finding problems. Traffic analysis can also be used to improve network performance, optimize data usage, and even enhance user experience. By understanding the flow of data, we can make smarter decisions about how to manage our networks. By understanding how data flows through our devices, we can make informed decisions about network configuration, app usage, and overall device optimization. This holistic view helps in creating a seamless and efficient digital experience for users. Now let's talk about the different ways we can analyze Android traffic. The first approach is called passive traffic analysis, and it's like being a fly on the wall, observing the data flow without directly interfering. Imagine you're sitting at a cafe listening to the conversations around you. You're not participating, just observing. Passive traffic analysis works in a similar way. We use tools to capture and analyze network packets, those little containers of data that zip back and forth between your device and the internet without altering their journey. This approach is great for getting a general overview of network activity. We can see which apps are most active, what kind of data they're sending, and which servers they're communicating with. It's like having a bird's eye view of the data highway running through your Android device. Now let's move on to active traffic analysis. This is where things get a bit more hands-on. Instead of just observing, we're actively interacting with the data flow, injecting our own packets into the mix. Think of it like this: instead of just listening to conversations at the cafe, you decide to join in, asking questions and steering the discussion. In active traffic analysis, we use tools to send our own specially crafted network packets to our Android device or the servers it communicates with. This allows us to test how the device responds to different types of traffic, identify vulnerabilities, and even manipulate data in transit. It's a powerful technique, but it also requires a deeper understanding of networking concepts and potential risks. Section 5, HTTPS Proxy Interception, decrypting the secure tunnels of your Android device. You've probably heard of HTTPS, the secure protocol that protects your data when browsing the web or using sensitive apps. HTTPS stands for Hypertext Transfer Protocol Secure, and it ensures that the data exchanged between your browser and the website is encrypted. It's like sending your information through encrypted tunnels, making it much harder for eavesdroppers to intercept. These encrypted tunnels are crucial for maintaining privacy and security in our digital communications. But what if we want to analyze this encrypted traffic? For cybersecurity professionals, understanding the data flow is essential for identifying potential threats and vulnerabilities. That's where HTTPS proxy interception comes in. This technique allows us to peek inside these secure tunnels without compromising the overall security of the data. It's like setting up a toll booth at the entrance and exit of those secure tunnels, allowing us to inspect the data as it passes through. Imagine a toll booth where data packets are checked and decrypted before they continue on their journey. This works by setting up a proxy server that acts as an intermediary between your Android device and the internet. The proxy server essentially becomes a middleman that can decrypt and re-encrypt the data. When your device sends a request to a secure website, the proxy intercepts it, decrypts the traffic, and then forwards it onto the intended destination. This allows us to see the data in its unencrypted form. The response from the server follows the same path in reverse, allowing us to see the decrypted data on both ends. This method is invaluable for cybersecurity analysis, helping us to ensure that our systems are secure and free from malicious activity. Section 6, bypassing SSL pinning, removing the roadblocks to interception. Now, savvy app developers have caught on to these interception techniques and implemented something called SSL pinning. It's like adding an extra layer of security to those encrypted tunnels, making it much harder for us to set up our proxy toll booths. Essentially, SSL pinning restricts an app to communicate only with specific pre-verified servers, making it harder for a rogue proxy to impersonate the real deal. But fear not, there are ways around this too. One common method is to modify the app itself, disabling the SSL pinning mechanism. This requires some technical know-how, but there are tools available to make the process easier. Another approach is to use specialized tools that can bypass SSL pinning at the network level, without needing to modify the app. Section 7, the man in the disk, analyzing traffic directly on the device. So far, we've focused on analyzing traffic as it travels between your Android device and the internet. But what if we want to see what's happening directly on the device itself, even before the data leaves the app? This is where techniques like file system analysis and runtime instrumentation come into play. It's like having a tiny technician living inside your phone, observing the data as it's being processed by the apps. We can use specialized tools to access the device's file system, looking for log files, databases, or other data remnants that can reveal insights into app behavior. Runtime instrumentation allows us to inject our own code into running apps, giving us real-time visibility into their inner workings. Section 8, benefits and ethical considerations, the power and responsibility of traffic analysis. As we've seen, Android traffic analysis is an incredibly powerful tool with a wide range of applications. It can help us troubleshoot network issues, identify security vulnerabilities, optimize app performance, and even understand user behavior. But with great power comes great responsibility. It's crucial to use these techniques ethically and responsibly, respecting user privacy and legal boundaries. Unauthorized interception of network traffic can have serious consequences, so always ensure you have the necessary permissions and legal grounds before proceeding. Section 9. Conclusion. Unlocking a world of insights with Android traffic analysis. So there you have it, a crash course in Android traffic analysis. We've covered the basics of passive and active analysis, explored the ins and outs of HTTPS proxy interception and SSL pinning bypass techniques, and even touched upon the world of on-device analysis. Whether you're a developer, a security researcher, or just a curious tech enthusiast, understanding traffic analysis can open up a world of insights into the inner workings of your Android device. So go out there, explore, experiment, and always remember to use these powerful tools responsibly. Stay curious, stay safe, and keep those packets flowing.